Welcome back to some iPhone programming fun. Today what we're going to be talking about are properties, protocols, and polymorphism. Admittedly, they all start with the letter P. I probably could have listed a few other topics in there. Just kind of a look at where we're at. So this is the course website, if you go to the iOS programming course website. So we've kind of been coming through the lower levels of learning about Objective-C. We're kind of continuing that today. Eventually we will come out of the lower levels. You can see we've got some things coming up with Quartz, UI views, core graphics. We've got a few more things that we want to cover with the low-level Objective-C learning skills. And today we're going to cover a bunch of those. So that's the focus for today. Properties, protocols, and polymorphism. The 3 Ps lecture. The other topics we're going to talk about memory management and inheritance as well, but those didn't start with the letter P, so they weren't part of the title. So in order to make this example go today, we're going to make a new project. We're going to call it 3 Ps with employees. For this example, we don't need any graphic stuff, so we're going to again use the command line tool, which is what we use for the fraction class. You can see that this is actually a Mac OS X application, but we're learning about Objective-C and the low-level Coca stuff, so it doesn't matter that we're not in the iOS. We don't need any graphics, we just want a command line tool. Foundation is just fine. So let's go ahead and give it a name. Let's call it 3 Ps with employees. You too can become a professor someday and pick silly little names to entertain yourself. It is one of the best things about being a professor. All sorts of ways to entertain yourself. Since I've done this once before, I'm going to have to add the word video or else it's going to complain I've already got that project. So what we're going to do here, we're going to first make sure we're up and breathing. So just to kind of make sure that everything is all good today, just go ahead and change the hello world message and just go ahead and type in the title of the lecture. So I'm going to go ahead and just copy paste just because it's a lot faster. You should be able to copy paste as well. So you should be able to click on the link and it should open up a PDF version. But you should be able to copy paste from it as well. It makes life a lot easier, copy paste. If I want to make sure this is running, I'm just going to hit Command Return. It'll save it and build it and run it for me. When I save it and build it and run it, it kind of feels like nothing happened. It just says it ended normally. But if I hit Command-Shift-R, I can see that it did in fact print out the message, properties, protocols, and polymorphism. Now let's go ahead and make things a little bit bigger here for recording the video. I'll make my font a little better for you here today. Cool. So the first thing that I want to do is talk a little bit about memory management and objects and object creation. So if we were to type the line ns-string star Bob name, what that does, if we wanted to kind of start up our box and pointer diagram, is that makes a pointer object. It makes a pointer to, it's expecting to get connected to a string. The pointers made like this go on the stack. You are not responsible for their memory. There's no memory management concerns. But it does make location in memory for this pointer type. So pretty exciting start. Let's go ahead and add some more code to that. Let's go ahead and add the creation of an object. This first object that we're going to create here is we're going to use the ns-string convenience initializer, or alloc and init, where you just say at and then you just put it in quotes. This does make an ns-string object, but it does it kind of weird. Let's see how it's kind of weird. So right now we say Bob name points to object with retain count, and then we're going to print out that object's retain count. So anything that's a subclass of ns object has a retain count property. And you can see what its retain count is at any time you like. When the retain count is greater than 0, it still exists in the system. When it hits 0, it's gone. So you can see I create the object, print something out about it, and then I release it here. If you go ahead and run this, something that might be surprising to you happens. It prints out Bob name points to an object with retain count -1. That might seem kind of odd to you, but it is actually what you should expect. And the reason for that is that this convenience alloc and init puts things into the program memory. So it puts it into the flash, the non-volatile, so it's not part of the heap. And anything that's a constant like this doesn't use the retain count mechanism, so it actually gets a retain count of -1. However, don't be fooled. Some people see this and they're like, NS strings don't use retain counts. That is not entirely true. The fact of the matter is it depends on how you created the string, which is kind of interesting. Let's look at some different ways that you might create strings. So option number 1 we've just seen. It goes on the stack. Option number 2, we could say NS string alloc. So you see the keyword alloc. So you might think that this one's going to use a retain count. But it points to, and then here you can see we use the convenience again. If I run this one is still a -1, so that's still a -1 retain count. This one we already discovered was a -1 retain count. Let's look at some more. This one says init with format, so it's going to be Bob something. I put in Bob 7. So what do you think? On the stack, or sorry, on the heap, or in the constant memory? Oops, I commented out this one below. Surprised it didn't cause trouble. So it looks like that one has a retain count of 1. So this one is actually put on the heap. And the reason it's put on the heap is because it can't go into constant memory because it doesn't necessarily know what it's going to be when the preprocessor goes through. It turns out it is just always 7, so maybe a smarter compiler would put it into the constant memory. But the choice here is to make it part of the heap. And the rest of these are actually going to be part of the heap. This one is an init with C string, which is another way you could do it. It's part of the heap. And then this last one is kind of different. So this last one, instead of making an NS string object, we're making an NS mutable string object. We haven't really talked about the foundation class or the foundation framework that much, but most things like NS array is immutable, but there is a subclass of NS array called NS mutable array that can be changed. So that works for NS string, NS mutable string, NS array, NS mutable array, NS dictionary, NS mutable dictionary, NS set, NS mutable set. You get the idea. So a mutable one can be modified, and mutable ones always go in the heap. There is no such thing as putting a mutable one on the constants. They have to be part of the heap, so it's got a retain count of 1. So what we're doing here, if we wanted to draw a box and pointer diagram, we're creating Bob name, which is an NS string pointer, so it's going to point to an NS string object. And then on the heap, we have created an NS mutable string. Whenever you alloc an object, it makes space on the heap, which is part of the dynamic memory. It knows what type of class it is, for one. It makes the retain count mechanism, and then it makes enough space to store whatever it needs to be stored. So here you can see it's actually keeping kind of an internal static array of these. They're actually in Unicode. So I guess they're 64 bits each, and then some type of null terminator. So it makes how much space it needs, and it puts that space out there. So this is what we've done with this code. Cool. Do a couple other fun things. When you're playing with memory management, the keywords are retain and release. No real reason to do this, but you can add retains to things. And then if you want to be a good memory management citizen, you have to match the number of releases. So if we were to run this, it should get up to a retain count of 3. So we're just kind of playing around here with retain and release. So the way that this got up to 3 was 1 for the alloc, 1 for each retain, and then it got up to 3. So that's just a little bit to get us started with memory management. So let's do some more stuff. So what this lecture was all about was properties, so let's talk about properties. In order to learn more about properties, we're going to make a class. We're going to make an employee class. So this employee class, we'll just go ahead and say right-click and say Add New File. We're just going to go ahead and make it a subclass of NSObject. So I went ahead and picked Mac OS X, Coca class, Objective-C, subclass of NSObject. So kind of the most basic. And I'll just call it employee. For this employee, what we want to do is we're going to show you about properties, so we kind of just have to make a couple. Again, copy paste is your friend. So just really quickly here, I made 4 ivars, name, employee, manager, working. Should be very familiar with NS strings. Should be fairly familiar with bools. Bools are interesting. You might have expected it to be called Boolean because C uses something called Boolean. However, Boolean didn't join C until the C99 standard, whereas Objective-C has been around since like the early 70s, right? So it was called Bool because Boolean didn't exist yet when they made Bool. Also interesting is that working with Objective-C, instead of using true-false, they typically use yes-no for bools, which is kind of neat. The one that might be new to you, though, is this one. This is an NS number. NS number is an extremely simple object. The reason you might use NS number is it is an actual object that's a wrapper for a primitive. So in Java, you've seen this with the capital I integer class, the capital D double class. In Objective-C, there's only one. It's called NS number. It's a wrapper for all different types of numbers. So you don't necessarily know how it's stored under the hood, but you can, it's impressively simple. You can make an auto-released number with a char, a double, a float, an int. You can initialize it to give it a retain count of 1, and then you can get the values either as a bool, a float, a double, whatever you want. And that's pretty much it. It doesn't really do much else. It implements a compare method and also an is equal to see if things are equal. But that's really about it. You can also see what type of variable it's using under the hood if you want. So a really simple class. We're using it today because we want to play with objects and memory management. Primitives aren't much fun with memory management. We've got working on here, but it's for a specific example. So we've got our typical header file, ivar, properties with the same name. Let's go ahead and write the implementation for this. So kind of the most basic implementation would be that we synthesize all of our properties, just like we've always done. And then now is a good time to be good memory management citizens. So we go ahead and release all of our objects. Note that we have 4 synthesize, 4 properties, but only 3 releases. That's because bools are not retained, right? So you can see that these are all retained. This one is a primitive, so there's no retain for that. So there's no releasing it. It's not an object. So we release those. So that's what we've done in the past. Now we're going to introduce something different. Some people use a different naming scheme whenever they deal with ivars and properties, and it's got some advantages. Let's go ahead and do it first, and then we'll explain why. So this scheme is like this. For the ivars, you put an underscore in front of each one. So you say underscore name, underscore, underscore, underscore. So the ivars have underscores. The properties do not. And the way you tie this together is in the synthesize. So you can say that you want to synthesize the name property using the ivar underscore name. These are entirely different things. I could have called them anything I wanted that could be completely different. But this naming convention is to use the underscores. Looks like I've got a couple extra spaces. And there is a reason for doing this. I need to also fix my dealloc method. So what I'll just tell you what you release is you release the underscore version, which is the ivar, and not the property. We'll explain more about why that is. And the reason is that these are actually very different things. Underscore name is a pointer to an object, whereas name, the property name, is actually a method. So you're synthesizing two methods. So you're synthesizing a getter and a setter. So name is just a pointer. It's just an NS string star. Whereas if you call something like self.name, that's actually a method. In fact, it's two methods depending on how you use it. If you were to say self.name equals, it becomes a setter. And if you were to, say, self.name and set it to something else, oh, here I've got Bob, I should have said self. That would set it to something else. So it's actually a getter and a setter depending on how you use it. So they are extremely different. One is a pointer, the other is a method. Two methods. Now it turns out that the way you use them is of course very similar. Let's go ahead and write a description method. So what I've done here is I've shown you two different ways you could write a description method. You will use one or the other, don't use both. I'm just showing you that they are very, very similar. So what we're doing in the first one is we are actually calling the method for employee ID. What that does is that calls a method, and that method turns out to have a return type of type NS string star. So they, in effect, with the getters, they work almost exactly the same. You don't really see the difference until you start working with setters, and we'll start getting into that. So I'm going to pick the top one to use. I could have just as easily picked the bottom one. In this case, they are identical. They don't have to be identical. You could do some funky things with your getters, which we're going to do later. But for now, they were identical. They are at present identical. So let's do a couple more things. Let's go ahead and create one of these objects. We'll call him Bob. And let's do a couple things with Bob. So what we're going to do is we've got Bob name. And what we're going to stick in here is we're going to create a new object of type Bob. We're going to use the default initializer to start with, so we can't pass it any values just yet. We're going to set Bob.name equal to Bob name. So here you can see Bob is Bob name. He's going to be set to Bob.name. And then we're going to do some things. We're going to compare Bob name to Bob.name. So the real question is, what is the retain count before this assignment? And then what are the retain counts after? And then to be a good memory management citizen, we release Bob after we're done with it. So if we were to run this, oops, it says that it has no idea what an employee is. That's because I did not yet import my employee class. Much happier about building. So if we were to run it and hit Command-Shift-R, what we see is we got Bob name up to 3 prior to this assignment, and then once we assigned it to Bob.name, you can see then it hopped up to 4. And Bob.name and Bob name point to the same place. The reason they point to the same place is that right now we're using a retain. So if we wanted to draw an image, I'm going to skip ahead and then come back. If we wanted to draw an image of this, we could say that we've got on the stack Bob.name. Also on the stack we've got Bob, which points to this object, this employee object. And then inside here he's got a name, and these two point to the same place. And right now its retain count has gone up to 4. Let's go back a little bit. So this Bob.name is actually calling a method. The method that it's calling, let's go ahead and look at how we could have done this. We could have, instead of saying Bob.name equals that, we could have just as easily said Bob set name. So this method, Bob.name, actually just gets converted directly to this. And the one below it are completely identical. So these two are completely and totally identical. They're the same thing. Likewise, the getters, there's two ways to do getters. You can say kind of with the method syntax, the messaging syntax, or the dot syntax. These two are the exact same thing. They do the same thing. So let's just go ahead and leave it with using the method approach because it looks cool. And we can see that if we build it and run it, no big surprise, nothing changed. So it's important to know what the dot syntax really do. They call methods. That's what the dot syntax does. This is kind of different from Java. So like in Java, you could say like, this dot and then the name of one of your class's properties. And it's kind of the same with or without the this. This one's totally different. One is a method, the other is a pointer. Totally different. And that's why the underscore convention exists. So you can really see that they're totally different, right? Pointer, method, different. All right, said it enough. So let's start looking at some details that you can put into properties. So right now we defaulted all of these to retains. So right now it's a retain. There are actually 3 options that you could pick. You could pick assign, retain, or copy. We're going to go through each one and we're going to kind of see what each one does. Probably from the name you have a good idea of what they use or what they do, but we're going to kind of go through them in detail. So let's go ahead and start off with retain because it's the one we're looking at. So what retain does is it makes the IVAR point to the same place. So there's only one object, and it increases the retain count. So the retain means it's going to increase the retain count. So it's going to point to that thing, and it's going to throw a retain on there. Another cute trick that you can do if you want to prove that they are in fact the same thing, you can use the debugger. This is more to show you the debugger than anything else. If you want to use the debugger, you can click in this number area. It'll put this little blue breakpoint on here. And if you say build and run, it'll build and run using the debugger. The first time the debugger runs it was a little slow, but you can see it hit my breakpoint and it stopped there. You can use the mini debugger here to like step over, or you can bring up the real debugger. You can click on the icon, or it's Command Shift Y. The debugger can be a really useful tool. It exists in a lot of development environments. Xcode also very useful. And you can see that we've got a local variable called Bob name. It's pointing to an object at this memory address, so 380 is kind of the end. And then you can see that Bob points to an object that is located at address 380 as well. It's the same object. It's just kind of neat that you can prove that with the debugger. So same object increases the retain count. Now let's do something kind of crazy. Since this is an NS mutable string, what would happen if we were to say change it? So if we were to change Bob name, so we're changing, whatever Bob name points to, And then if we were to print out Bob.name, let's go back a couple slides and grab where I can print that out. As you can probably guess, it's going to change it, right? Because they're the same object. Get rid of my breakpoint. By the way, to get rid of breakpoints, you can just hold down and just drag it off, and it'll just go away. It's kind of fun. Oops, let's go ahead and finish this run. Look at our console with Command-Shift-R, and you can see if I scroll to the bottom here, you can see it says Bob Fisher, right? So since they point to the same object, you can see it actually changed it, right? Cool, so we'll kind of keep going here. So that's retain. Let's look at the next one. The next one is assign. So with assign, what we're doing is we are using the same object, just like before, except we are not putting a retain onto it. Likewise, it does not release old things. That's the other thing I should say. If you set it to something new, it'll release what it was set to previously, and it'll retain on the new one. Also, if you use an assign here, there is no reason to release it in the dealloc method because you don't have a retain on it. There's no reason to bring it back to 0 here if this object goes away. So you've got to be a good memory management citizen and do that. And if we were to build and run it with assign, you could see that now it's 3 before, and then when we assign it, it stays at 3 in its retain count, and Bob's name is changed to Bob Fisher. There is no person named Bob Fisher. It's just kind of a silly made-up name. Fisher is my last name. So that's assign. Assign is actually very useful. Assign is useful for things that aren't objects, right? So for anything that's not an object, like a primitive, you would use assign. Also for delegates. When we get into talking about delegates, they need to use the assign keyword. Assign is also the default. So if I were to delete the word assign, it would use the default, which is assign. So deleting it or having it, same. Doesn't matter, it's the default. So what people do a lot with strings is they actually use the option copy. So instead of saying retain or assign, we'll say copy. Now with copy, you do need, copy does put a retain on something, so you do need to release it. So let's put that back. So copy is interesting. So if we were to run copy, you can see that before it got it up to 3, and then we did the set name. This object didn't change, it's still at 3. Bob name, however, points to something that has a retain count of 1. And now all of a sudden, this is a big change. Bob name now no longer says Fisher. So they're different objects at this point. So whenever we set it, we made a copy for ourselves. We didn't mess with your object. We made our own darn copy. And then whenever you appended Fisher onto this one, it didn't affect us at all because we made a copy of it, right? So kind of looking at the memory management here, you can see that we've got a pointer to Bob name on the stack. He's got an object which got up to 3, and then our employee points to a completely different object. So a completely different object. Another kind of neat thing happens is whenever you use the copy method, it actually is smart enough to make it the type of object that you wanted. So previously it was a string, or an NS string pointing to an NS mutable string, but now it's genuinely an NS string. You can actually prove that to yourself if you want by trying to do this, by trying to mutate Bob.name. By the way, the compiler, if I was to take off this typecasting. This is just a typecast. You can see that Bob name was a string. So if I tried to append something to a string, the compiler would yell at me, right? Now this one isn't in a string. This is kind of funny. If you typecast it, you can, it's almost like you get away with one because the compiler builds, right? I will say this is a kind of a problem with Objective-C is there are a lot of things that it lets you compile just fine on, but if you try to run it, so if I hit run, you can see that it says stopped, exception thrown. So it let me build fine, but it didn't actually say crash. It just says exception thrown. That's interesting. Oh, that's neat. So it paused so that I could use the debugger. I forgot that's a new feature. So you can see like where it, instead of just crashing, it paused for a second since I had breakpoints on. That's great. Now if you use it without the build and debug, it'll just crash and it'll just dump out uncaught exception. That's neat. I'd forgot about that. So if you do this, it does one thing. It pauses at a breakpoint, but if you do that, it does another. It's kind of neat. All right, so that fails. Tangent over, comment that out. That works out poorly. So you can trick the compiler, but you can't trick the runtime. Cool. So let's go ahead and keep on moving. The next thing that we want to do is we want to start making initializers. So let's go ahead and make an initializer for the employee class. The initializer that I'd like to make is obviously we could initialize and pass it all the variables, but I don't know, it's starting to get a lot. We'll come back. We'll work with these others. Don't you worry. But let's go ahead and make an initializer first. And then we'll come back and we'll show you some of the other things. We're going to pass it in a name and an employee. And what we're going to do in this initializer is we're going to make use of our properties that we've got. Another thing that you'll notice is that you can see that now we can just pass in a pointer called name and a pointer called employee ID. There's no name conflict because our pointer is named _name, and we have a method called name, but there's no name conflict, which is kind of slick. So I kind of like the underscore just because then you can make initializers that are really simple to come up with names. You could always use like a name and things like that. So what we're going to do in our initializer, just like you've seen before, we're going to say if, then we're going to say self equals super init. So it's going to call the super classes initializer. Make sure that returns something that's not nil. And then inside of it, we're going to set, we're going to use our properties so that now we're going to actually make a copy of whatever the name was. And then this one's going to use the default retain. So now let's go ahead and switch it over to use our initializer. So instead of doing it in 2 lines, let's just do it in 1. But they're really doing the same things, right? So these 2 that are just commented out and this one doing the exact same thing. So you can run it and you can make sure that everybody's good and happy. So it's using the copy just like we wanted with the property. Next feature I wanted to talk about is the writability. So properties, the way you can think about them is these are instructions for how you should make the synthesize methods. So you can see that we've got copy, assign, or retain. These are useful for how you're going to set, how you're going to make the setter. But kind of even a higher level is whether there's going to be a setter or not. So if you say read only, then there's just a getter. If you say read write, then there's both. Read-write is the default, so if you leave it off, you get read-write. If we were to change this to read-only, there would be tremendous unhappiness. So if you try to build it, it says no setter found, because here we're using it as a setter, but here we're saying that there is no setter. So you can see how if you want a setter, make sure you make it read-write. The one kind of annoying thing is you've kind of made it publicly read-write just because you want to use the setter. There are ways you can get around that, but for this class, we're not overly worried about it. We're going to assume you're the main one using your classes. So read-write is the default. If you want both, if you only want the getter, you can say read-only, your choice. Read-only is a good way to protect your IVARs. And this is the example that we just did. The last thing is you can see that we removed the non-atomic. So non-atomic is all about threads. If you're making a program that has threads, then perhaps you want it to be atomic. Atomic just means that nobody could possibly interrupt it. No other thread could use the processor. If another thread wants to access that IVAR, one thread will completely finish first. So what it does is it puts it into like a synchronous block. If you are not using threads, you can add the word non-atomic, and it'll be 1 billisecond faster. If you are using threads, just leave it off, and it'll make it thread safe. The other thing is if you don't know how your class is going to be used, if you're making it for somebody else, you might choose the atomic option just because you never know what they're going to do with it, right? So that's kind of up to you. So for this one, I'm going to choose to say copy, and then I'm going to accept the defaults for everything else. If you wanted all defaults, that's totally fine. You can just leave it blank. Just take it out, and you get all defaults. Nothing wrong with that. Here I want, the only non-default I want is copy. It's also kind of crazy that there is no atomic keyword. You just have to leave it blank. Just wacky. The last thing that you can do with properties, so properties describe how the synthesized methods are going to get made, is you can actually change the name of the getter or setter method. This one's wacky. About the only place you see that is you see that some with bools. So with bools, they'll do this. They'll say, it would make more sense in my code if the getter, instead of saying like, Bob space working, it'd make more sense or if the getter was is, and then whatever the property is. So we're going to make the getter is working. And then you can make the same choice about whether you want non-atomic or not. Doesn't matter for this project. So to show an example of this, you can also change the setter, but almost nobody does that. It's pretty much only used for bools. So what this looks like is if you wanted to set whether it's working or set and get it, let's just go ahead and put it in. Put it in, then I'll comment it out. So if we wanted to say set working, if we wanted to make it true, then we could print out whether it's true or not. A bool is really just an integer variable type. So you could, if you wanted, you could print out just like %d, and it'll print out 0 or 1. But you see a lot of people use this trick. Instead of printing out %d, which is 0 or 1, which doesn't look very pretty, they print out the descriptor. And then what they do is this. They use this ternary operator. You've probably seen this from C. So if is working is true, then it puts in yes. If it's false, it puts in no. So let's just go ahead and see this in action. So if I run it, you can see that the first line prints out Bob working equals 1. But then the second one with the ternary operator says Bob working equals yes. And it just makes your logs look a little cleaner. You can see that here we said is working. You can still use the dot syntax. You can say working equals no, and then this one's always kind of weird. Should you say Bob.is working, or should you say Bob.working? Before you had to say Bob.working, although somebody told me that they typed in is working and they've made it to where that works too now. That's fine. But typically I always use the actual property if I use the dot. If I use the message one, I'll use their new getter. So we'll go ahead and comment this out, but I just thought I'd show you that just because sometimes people are confused, especially about the bools. Personally, I kind of wish they hadn't even messed with it, but that's fine. There's a standard now that bools say is before it, and you should expect that standard, and you should follow that standard. Even if I don't like it, it's the standard, right? Other things that we can do. So we've been talking about changing the properties and what you could do with those. You could also make changes to how the synthesizers work. So the first thing we're going to show you is not using a synthesizer. So what we're going to do is we're going to not use a synthesizer for the employee ID. So inside employee, currently we're synthesizing the getter and the setter for employee ID. Let's not do that. If you choose not to synthesize it, that's totally fine, but you better implement them yourself. This one is read-write, so we're going to have to make both a getter and a setter. So what we're going to do, I probably should have done this one in phases instead, is we're going to start off by making the getter. The getters are always of the same form. They take no parameters, and they return the type that you want to return for that IVAR in this case. So this is an NS number. Getters are extremely easy to write. You pass the pointer back, so you can see why those two descriptors were the same, because it's very simple. You just pass the pointer back. However, you don't have to. If you felt like it, you could return something totally different. So just for fun, if somebody asks for the employee ID, I'm going to give them 42. There's obviously no reason you would do this, but I'm just showing you that you could. So if you write your own, you can put in custom implementations. Let's look at the setter. So the first thing that you probably would have thought to have done in a setter would look just like this. So I'm going to comment out this for now. So the first thing you would have thought to have done would be to just, if somebody passes you a new employee ID, you would just say new employee ID equals employee ID. This works fine. The setter that you have just implemented, if you write this, is the assign setter. So this is the assign setter, very simple. So if people wanted to use a retain, the first thing that some people might think to do is this. So you just say self.employee ID equals new employee ID. What is this? What did I just do? I made an infinite loop is what I just did. This function is set employee ID. This method right here will get expanded to read self set employee ID new employee ID. So these two lines are completely identical, and I think this one makes it quite obvious that you just made an infinite loop. This is bad. This is terribly, terribly, terribly bad. Inside the property, you can't say self dot. You can't use the property within the property. You make an infinite loop. So let's look at a better implementation. So the implementation that is kind of the most foolproof is to say, does this point to a new object or not? Am I actually like changing what I'm already pointing to? If I'm not making a change, then do nothing. That's kind of it's an easy way to avoid some problems that come up that I won't go into. If it is something different, then what I'm going to do is I'm going to add a retain to that new object, so bump him up. The next step isn't very important, is I release whatever I was pointing to. If I was pointing to nil, there's no harm. It sends a release to nil, which does nothing. But I release whatever I was pointing to, so that'll free him up. I'm no longer an owner of whatever I was pointing to, and then I assign the pointers. So there's this very careful check to make sure it's different, retain the other one because I care about it, release the old one. So what we've just implemented here is we've implemented the retain method. If you want to implement copy, you could do that too. You just have to use a copy method. I'm not going to go into it, but you could implement a copy synthesizer. So this is writing your own getters and setters. We could test them, right? They'll work just like you'd expect. They work just like they did before. The only difference is now we made our own, right? So nothing big there. Another thing which can be useful is to kind of make a hybrid of the two. So what we're going to do here is we're going to leave synthesize on. So it's going to synthesize a manager. Let's say I wanted to do something different for the getter only. So I'm going to choose to override just the getter. Objective-C is very smart. If you say synthesize, but then you also implement one of them, it will use your implementation. So it will use your implementation here. So if you wanted to add some custom stuff, you could. So for example, here we're saying if the pointer is pointing to nil, so it's not known who the manager is, instead of returning nil, return the NS string unknown. So you can choose to do that. If there is a manager, and it's your manager and you want to be very formal, you could add a title. So Mrs. And then whatever the manager is. So this is how you could make a hybrid of a synthesize method. So you still synthesize, you just make your own where you want it. Another thing you can do, which is kind of wacky for people that are new, but it turns out to be really handy, is you can make properties that have no ivars. There does not need to be a one-to-one relationship between ivars and properties. You can make a property without an ivar. I didn't have a good example of this, so the property that I made is called name. So it's just going to return the name concatenated twice, right? This is useful, even though I couldn't think of a good example for it here. It's used a lot when we start talking about UI views with the frame property. There is no frame ivar. We'll get to that when we get to that. But you can make properties to things that are not ivars. There is a catch. If you want to make a property that's not an ivar, you can't use the synthesizers. There might be places where you could, but in general you can't. So if you want to make a property without an ivar, you have to write the methods yourself. This one's read-only. I did that so that I would only have to write the getter. And the getter for this one is fairly easy. And so the getter for this one is just going to return a string with format, and then I just have two print object descriptors for name and name. Usually the properties are based on the ivars, but they're like a different permutation. So let's say I wanted an ivar for first name and last name, and then I wanted a property for those plus full name. I could do things like that. Just to see it in action. It's a pretty simple thing to see in action. So here we print out Bob name. Let's go ahead and print out Bob's name. And so I can say Bob name. And you can use the dot syntax. It's property. Feel free to dot syntax your little heart out. So if we were to see what this printed, we should say that Bob's name is Bob. So it's a property without an ivar. Not a hard concept, but a useful thing. This one wasn't useful, but it is a useful idea. So I think now we're going to go ahead and take a quick break, in that I'm going to end this video lecture and start a new one. So just because it's getting a little long, we're going to break it up into two pieces. So this one we talked all about properties. We also got through some memory management stuff. So the things to go for the next video will be protocols, polymorphism, and inheritance. It just didn't start with a P. So I'll go ahead and stop this one now. Catch you next time.